Hello! In this video, I'm going to introduce you to another component which you'll find in your Pico kit. Have a rummage around and see if you can find a little plastic bag which has got a blue little plastic box inside it. It should also come with a little separate small bag of some extra pieces. We'll learn about those in a moment. What I'd like you to do is to take this out of the bag. Now it might be that there's a little bit of oil on it, so you might just want a bit of kitchen towel as you take it out just to wipe it off. That is because there are moving parts in here, and when it was manufactured there would have been a little bit of oil that would have been put inside these mechanisms here. Can you see there are gears, toothed wheels in here, and these will all move. So anything which has moving parts, we want to make sure that it all runs smoothly. So a little bit of the oil may have come out during transportation. So clean that up. So now you've got a nice clean little casing here. So now you can take a look and see if you can spot what's inside. At the bottom, you can see a little green circuit board, and there's a chip at the bottom, a little black chip there with looks like 8 legs on that. And at the top you can see all of these gears. It looks like it almost might be a clock or something in there with these toothed wheels all interconnecting to each other. And on the top, this again has got some little teeth on it, and this is the bit which will be moving for us. Then we have some cables coming out of it. We've got 3 cables coming out, a brown, a red and a yellow. Now you might see on the side that it's got a label. It says micro servo, 9 grams, SG90. Now a servo is a special kind of motor, and it's not the sort of motor that is going to make a little remote control car whiz really, really fast all the way around a circuit. But it is the sort of motor which might help that robot maybe have a mechanical arm that might lift up and flip its opponents, or it might have a little kind of claw that might grip things and move things. So this servo is for small movements, and hopefully they can be quite strong movements. So even when the servo motor isn't doing anything, these teeth should keep the arm or whatever's connected to this in position. So it's really important that when you're taking a look at this, that you don't try to turn this top bit here, because this bit should be connected to and is connected to and controlled by these toothed wheels underneath, and we are going to control the position of this wheel on top through our electronic connections here, through the cables. Okay, so we are not going to try and twist this at all. Now if you get the extra little bag, you will see that in here we have got a number of different arms that we can put on top, and it's up to you, of course, which one you use. To start with, I would recommend the one which only has a single arm on it, because the others are sort of double pointed. And you will find that you'll be able to pop this on, and it should just fit on quite nicely. Now there are screws in this packet. We're not going to use those just yet because we don't know what our final position of this, what we want that to be. So this, you will just be able to push this on, and that will just sit on top. And then finally we should be able to put a screw in there should we choose. So this arm is now going to do some moving, but in order for us to control this servo, there's a little bit of work that we need to do. Now you can see on my board that I have got a clear board, just to make it really easy to see what it is that I'm doing now. You can keep some of your other connections on. You don't need to clear your breadboard at all, but I'm just doing this to keep it nice and simple. What you're going to need is you're going to need 3 pin to socket connectors, because at the other end of this we have a little triple socket here. Now, if we had 3 pins that were just in the right positions, that I could just plug this down onto my Pico, then that would be great. But unfortunately, that's not how it works. I've not got pins right next to each other, so I'm going to need to take, and I've just got here a set of 3. They can be pulled apart. I've just kept mine together a little bit. I've pulled the ends. 3 pin to socket wires. Now the colours don't have to match, of course, but we're just going to pay attention to which ones we plug into which colour on here. So as I put them in, I'm just going to stick each of them into there one by one. And now you can see that I've got a brown wire, which is going into, my brown wire is going into blue, my red turns into purple, and my yellow turns into a sort of grey-white colour. Okay? So all I need to do is maybe just make a note of that. So now what we're going to do is we're going to give this little servo some power. Now there's a couple of ways to do that. We can use the VBus connector, which is at the top right of our breadboard here, and our power is our middle wire. So my red wire is going into purple. So I can take my purple and I could bring it over to the VBus. I could also take it straight over to the 5 volts if I wished. Now my ground is brown, and they kind of rhyme, don't they? Ground and brown. So my brown, whichever colour you've got plugged into your brown wire, so mine's blue, that is going to go to ground. So again, on my board here, just 2 pins down from the VBus, I've got a ground connection. So that will go in there quite nicely. And now the final one should be going into the yellow cable. So the yellow is going into my grey, and this is going to come over to GP0, which is over on the other side of the breadboard here. So there are my 3 connections. I'm using GP0 for my yellow cable, my signal. I've got ground, that's my brown wire, and my power is the red wire, and that is going into VBus. Okay, so if you just need to sort of make a note of how your colours connect up, then just pause this video and make sure that you're happy that you've connected yours in the right way. So before we go any further, we're going to need to get a little bit of code, which is going to function as a library to help us control our servo. So thanks to Random Nerd Tutorials, we've got a great bit of code here, which I will put the link to in the video description. And this is on a GitHub repository for code to do with the course, if you're following my courses. In this folder, we've got a file called servo.py. And what I'd like you to do, when you get to this folder, is to click on servo.py, and you will find this code, which, as I say, has been written by the Santoses at Random Nerd Tutorials. So shout out to them for creating a really great library which is going to help us to control the servo in a really simple way. Once you're in here, as long as your cursor is in here, you should be able to select Control A to select all of it. And then we're going to copy it. So Control C. And now I'm going to bring this over into Thonny. So I'll come over into Thonny and I'm going to open up a new file and I'm going to paste it in. And there's quite a lot of code. It looks quite complicated, doesn't it? It's doing all sorts of things in there. And if you follow my IGCSE course, you'll learn a little bit more about pulse width modulation and what that means. For now, though, we don't need to understand what's going on in here, but we do need to save this code to our Pico. So I'm going to click on Save. I'm going to click on my Raspberry Pi Pico. I know you can't see this here. And then I'm going to save it as servo.py. And then that should appear in my files section of Thonny. So if I now go up to view files, then I should be able to see it in here. I haven't actually saved it. So I'm going to save it as servo.py. I'm going to click on OK. And there we go. You can see that I've saved it in here. Now, if you're feeling like you want to organize things really, really nicely, we could save it into the lib folder here. So we could just double click on there and you can see I've actually saved it in here as well. So that would be the best place for it, into the library kind of folder there. So it doesn't really matter. The Pico will be able to find your code wherever it is that you have saved it, as long as servo.py is written exactly like that, then you will be able to run the next bit of code. So now I've got the servo.py library saved onto my Pico. Now I can create some code to control it. So I'm going to create a new file, and from this servo library, I'm going to import an object called servo. And you can see this is a standard practice that the library name is all in lowercase, but the object that we're importing has got a capital letter at its start. So that's why we have from servo all in lowercase. That's the name of the library. We're importing an object called servo with a capital S. And that is what we are now going to tell our Pico. Yeah, by the way, this servo, I've plugged it into GP0 over here. And that's what this line is doing on line 5. I've called it my servo. You can call it whatever you like. And it is a servo object that we've just imported up here. And it's gone into, or the yellow wire, the signal wire has gone into GP0. Okay, you could use GP1 or GP0. Those are the ones that I would recommend for this. And you can see you're beginning hopefully to become familiar with this now, that from time we are importing sleep. And that is so we can just slow things down and give the Pico a chance to activate the servo and for our servo to do the moving. So now what we're going to do is we are going to do some experiments in moving it. So I'm going to say my servo dot move. And inside these brackets here, I'm going to be able to put in how many degrees I would like it to move to. Now, when I put in 0 degrees, that doesn't just mean I don't want it to move at all. So it's not a relative term to where it is. 0 degrees is an absolute position, okay? It's got a predefined position in these motors here. So if I set it to 0, it's basically going to, it's like it's going to rewind, yeah, and get back to the start if you've got an old-fashioned VHS or audio tape or something. So our 0 degrees is like returning it to its starting position. Now this servo can move through 180 degrees in total. So we're going to do these one by one and we're going to see what happens. So here we go. Okay, hopefully you saw that move. This is the 0 degrees position. So what I might do at this point is I might take off this arm because it's at a bit of a random position. And I might choose to set 0 maybe at right angles to the main body, or maybe in parallel to the main body. It's your choice, really, but you want it sort of in a position that you think, okay, I feel that that is a good starting point. So here is my servo at 0 degrees. I'm now going to rerun the code. Now I'm going to put in 90 degrees. Let's run it and see what happens. Okay, did you spot that? Hopefully you can see. The 90 degrees is definitely moved through 90. That looks pretty good. And now if I move it to 180, where do you think it's going to go? There it is. So we are now opposite to 0. Now you can see it's a little bit off. It might be 176, or it might not be exactly 180. We're fairly close here. And this library is good enough for us to use for our purposes. So we could now create a bit of code where we can whiz through each of these in turn. So here is my little loop here. So what you can see happening is I'm also printing onto the screen at the same time 0, 90, 180. Back to 0, and to 90, and to 180. And this is the sort of thing that you can now do to test your code, to work out what, sorry, that went off the screen, to work out which positions you would like your servo to be in. Can you maybe work out how to move it in increments? So that means in positions that kind of move up the same amount each time. So you could go up by 10 degrees, 15 degrees, something like that. Okay, sorry about that. I just lost my video feed. So this is your challenge now, to pause the video and to see if you can get your servo to move to whichever angle you choose. Have a good old play around with this, because in the next video we'll be learning how we can do some really fun things with this. Good luck.